All right, so just to continue where I left off, we're looking at creating data distributions from quantitative data. So here I showed you these were audit days. Um, I think I misspoke in the previous video. I kept saying that these were required audit days. These were actually recorded audit days. So if, for example, you went into client number 1 and you did an audit, it took you 12 days. Client number 2 went into an audit, took 14 days. And the other one took 19 days, 18 days, etc. So that's what we're looking at. All right, so we're going to create some bins. Here is an arbitrary bin that we're looking at. We want to figure out the frequency, relative frequency, and the percent frequency. So what does this look like in Excel? So let's move over to Excel and let's take a look at this. All right, so here's the year-end audit days. What we want to do is look at some simple ways of being able to evaluate these audit days. What I always tell students is if you were going to calculate some kind of frequency chart on audit days, there's ways to cheat. You can go ahead and insert a histogram using Excel, but let's kind of do a couple of things. We want to know the average number of days, or the mean, right? So this is going to equal the average of this data. And then the next thing we want to know is the median, standard deviation, the min, max, range, spell that correctly, and the count and the sum. All right, so do this real quick. So by the way, with standard deviation, we're always using sample. And I'm doing these real quick because the point of it is that you should have learned how to do these on your own. And of course, you can always slow down my video to kind of see what those values are. So now we have each of these. And one of the things I want to pay attention to are these blocks of data right here. So we have a minimum of 12. So if I was going to start some kind of frequency distribution, I would want to start with 12. And if I was going to look at the maximum, I want to end somewhere with 33. So if I had like a start block and then I had a end block, I would want to be looking at those two values. So that's something to look at. But to keep things simple, let's go back to our PowerPoint here and let's copy these audit days that they have here. So I'm going to copy this little table and then just go ahead and paste it right here. Right now in Excel doesn't like these kinds of ranges that well. So like it can't read this data because it ends up becoming really it's text. So we're going to have to put some values in here so that way we can read that text a little better. So we know that the start is 10 and the end is 14. And the next is 15 and the end is 19. 20, 24, 25, 29, and 30, and 34. Now there's other ways that we can go about doing this, but a couple things to point out with this. Okay, first of all, our minimum value 12, it is in this range. And we know that because 10 is lower than 12. So that's an important number to know. The other thing is this here, 30 to 34, our max is 33, so it's also within this range. You want to make sure that when you create distributions on numerical data or quantitative data, that it falls within your min and your max. If you don't, you're going to have errors. So what we want to do is that we want to be able to get a count of the number of records, meaning how many audit days existed in these ranges. And our PowerPoint gives us a nice little tool set on how to accomplish this. And it's actually right here, but it's not always so clear. And I want to be able to demonstrate this for you. Now, the instructions are right here at the bottom, right? It's using this frequency function. But let's kind of follow this closely. The first is to select the cells that are the ending point of our frequency buckets, right? Then we want to enter the formula that will include the data set and then the range that defines our buckets. Right, and then here's the magic. We have to hit Control, Shift, and Enter in order to be able to use this. So let's see if I can do this real quick. So the first thing that I want to do is I'm going to select right here, and I'm going to start typing equals frequency. Okay, my data array that it's asking for is this data. Right. The bins that I want to look at is the end right here. Okay, I'm going to finish that with a parentheses. So it's hold down my Control button, Shift button, and now hit Enter. There we go. So we should have 4 values that exist between 10 and 14. 8 values that are between 15 and 19. 5 that are between 20 and 24. And if I were to look at this, I'm going to go to Home. I'll do some conditional formatting, do some data bars. You can see I have a little distribution going on. All right, let's see if my numbers match up with the PowerPoint. There. Okay, let's kind of bring this here. And here is the one I want to look at, 48521. Coming back here, 48521. Perfect. So that's how you're able to create a distribution looking at quantitative data. Now, of course, we want to look at the relative frequency and then, of course, the percent frequency. So the relative frequency is this divided by the sum of all of this, which I will make into an absolute reference. Right, and then this is nothing more than that times 100%. Right, and I have to now format it so that way it's a percentage. And now, boom, good to go. All right, so going back to our PowerPoint and our lecture here, that's kind of where we leave things. So there is using creating a distribution from quantitative data, right? And there is the Excel format. So there's other tools that we want to be familiar with. There is histograms, and this is a visual representation of the quantitative data, right? And it's done by creating the value of interest at the horizontal axis, and the count of those measures is shown by drawing a rectangle at the from the horizontal axis to the height. What does that mean, right? That's easy to read off a slide. All right, so let's kind of look at the next picture. Here is a simple histogram. All right, I'm going to pick up on the next video, pause right here, and we'll continue on.